Some technical issues trying to get the chat going. Sorry about that, folks. Don't mean to be too unprofessional here. This is my new career. Anyways, welcome everyone to the NEStonia Build Challenge. I'm your host, Brad Taylor, and well, we'll have to see if the chat comes around. Anyways, we're going to be working on 3 parts today. We're going to be doing the 72-pin connector here. And we're also going to be working on... I'll try to do the STM32 micro there. And we're going to do all the 0.1 microfarad caps on the board. So, right, I guess we're gonna take this. We're gonna do this in a systematic approach, folks. So number 1, we're gonna find the unpopulated part. So let's find J1 here. Edit. So we got our 3D viewer here of the part, and we're going to say I want to see. And so that's what we're working on right now. Okay, and so we're just going to go to our bill of materials here and quickly look it up. That's J1 right there. Just going to take a look on AliExpress here. Be sure to select the color for NES. For NES 72 pin, and you'll see they have a lot of them. So yeah, there's that. And we'll just review the cartridge connector quickly. You know, NESdev, they're the authority on NES technical and otherwise. So that's your 60-pin Famicom connector, and then 72-pin NES connector. So that's what we're working on here. That was the data sheet. So so looking at the NEStonia schematics, which are available in the GitHub repository, there's your NES 72-pin connector, the cartridge interface, and then we've got some logic around it, that some tri-stating logic that that allows us to shut the cartridge off properly. Anyways, I'm not going to get too much into that. That's not what the show's about anyway. Okay, so we're going to scrub the board because, you know, it helps. It helps. So the way this works is we're going to tin all the pads, and then we're going to slip the connector on. But there is a catch. The connector has to be trimmed to 110 millimeters. It's super easy to do. So we're just going to put a little IPA in our cap here. And we're going to scrub the board. Just going to scrub it. Probably going to get a paper towel real quick. Hey, how's everyone doing? Is anything going on in the chat? Pull up the chat there. We'll have to see how that goes. YouTube Studios yelling at me. We'll have to review the stream later. See how it goes. Okay, good enough. Not the best idea to use paper towels because of the mouse bites. They kind of make a little bit of a mess, as mouse bites are supposed to, I suppose. We'll go with 330 degrees Celsius tip temperature for the soldering. All right. And we're off to the races. This is one of the more labor-intense parts to actually put on the board. But I will admit that it will make it trivial to remove. That one's a little bit... Okay, well... maybe a chisel tip would have been better. We'll have to try going this way because there's some useless knobs on this microscope that are kind of getting in the way. Kind of makes me wish I had removed them already. But that's cool. Little accident there. It's hard to do it this way. Yeah. It's hard to do it this way. We have to do it the other way. When it comes to soldering, it's all about technique. Good hand positioning, that's the key. Make sure you have a good fumes extractor when you do soldering. I mean, it's already hard enough, you don't need to breathe that stuff too. You know, I'm gonna assume that most of that excess solder is just gonna go on the pins. So the thing with the blade tip is that you kind of have to get flush with the blade. You got to make sure the blade is flush with the pad, or it will stick. So you'll notice that the 6337 solder, it doesn't bridge so easily. But actually the lead-free is even better. You could actually smear paste all over your parts, and it will literally just melt into place, and it won't even bridge. That one doesn't look great. It's a slow process, folks. The pad doesn't have any thermal relief. It's not too hard to melt the solder onto it, though. So, let's take a look. I'm going to do a close-up inspection here. See if we've got any problems. It looks like we got some almost solder bridges, like that. Like that one there is kind of... Yeah, I don't know. We have to do the other side still, so let's just move on. It's a challenge, folks, because I cannot see the microscope screen. Because I'm using the microscope as a web camera so that I can plug it into my computer and use it that way. And this compromises the ability for it to be used, or the screen to be used. Which means that I don't actually really get to see the thing too well. It's better than nothing, though. Sometimes you can get a rhythm. And shaky hands are always a challenge when it comes to soldering. Just letting you know, if you're one of those people out there that might have shaky hands, welcome, builders. So that one might be a wash. Did we get it? But I see another one. What are you doing? So there is quite a delay on the microscope versus what I'm doing, and so it's it becomes a little hard to navigate. Whatever. Let's keep going. By the way, if anyone knows a better way to do this, by hand, that is, feel free to reach out in the chat. Okay. All right, well, I think it's okay. So, let's see what we're doing now. So we got a few parts going here. Our printer just finished. I'm just going to set that up again. So here's our 72 pin connector. You'll notice that it has slotted holes, and so we're just gonna do this. You get the idea. So probably what we're gonna do is just bend them down a little bit so that we can put it on the board a little bit, so the pins angle down a little bit. It might make it more difficult to stick on the board, but normally we'd have something to put underneath the connector so it could sit flush. Well, anyways, we actually have to brush this connector. We have to brush it with isopropyl alcohol because it's dirty. It's dirty. And if you want the thing to actually stick properly without a lot of fuss, and I do because I'm on camera, we're gonna clean the connector. Like, I wouldn't clean most of the parts I'm gonna put on the board, but this I will. You'll use a lot of isopropyl alcohol in electronics because it cleans off board flux, which there's going to be lots of that. So, lots of board flux. I'd also recommend a conservative use of flux. Use it where you need it, because it's sticky. It'll muck up your stuff. So we're gonna use the screwdriver, push the leads down. Touch it with the iron. Getting the first one on is always a pain. We'll just leave that one for now. We'll tack the other side. Where is it? Doesn't look like it. Looks like a cold solder joint. We'll do all four corners, I guess, and then we can go crazy. Admittingly, this strategy is not as good as I thought it would be. But I mean, like, you don't want to mess with flux in the 72-pin connector, like, you know. So before we continue, we like to just make sure that the connector seems straight. So, you know, this isn't scientific, folks. It's it's pretty close, though. You can wiggle it a little bit, you know, but the idea is to get it centered after you do the first 4 pins, not after you do all 72. So we'll just continue in that same vein. And we're going to get this guy on here and increment our scoreboard. I guess we don't need that. Maybe we can get a little lower shot. Because I'm going to scooch down here. Oh boy, really? That's terrible. That's terrible. It didn't stick in either spot I soldered it to. Jeez. I'm having a hard time. I realized that I forgot to play the show's music. Forgot to play the music. You know, I think we're gonna need some flux. We're gonna need to put some flux on here because these pins, they're really dirty. I thought we could cheat a little with alcohol. Well, I hope it doesn't screw up the NES connector too much. So it's like 100% better. You might want to go with a flux paste or something. I think that's a better choice than using this stained glass flux we've got. This is one of the harder parts to put on just because it's it's the most physically involved. So this is going okay. Yeah, I guess the trick is to not use too much flux. Sorry about that, folks. Sometimes I'm not paying enough attention. That one took a lot of heat. All right, so let's do a little inspection. We got another side to do still. This is the hard one, folks. This is the hard one. That's why we did it first. Well, we got a solder bridge there by the looks of it. Or do we? I guess not. Seemingly that was just debris, I guess. So, not too shabby, considering we haven't actually cleaned it. We could probably redo that. Those early ones. I think we're going to call that one done. And besides, pin 37 isn't used anyway, so. Guess we're going to have to do this again. If you're really paranoid about the flux and the connector, maybe you could give the connector a clean with alcohol. And if you're wondering how you do that, the easiest thing would be to just find a 72-pin card edge. Maybe some cheap NROM game or something. And just put a piece of paper around it and get the paper wet with alcohol. Shove it into the connector a bunch of times, in and out. And you could clean it that way. However, that looks good. One of the fun things about electronics is when you get a momentum. Sometimes it's hard to understand what's actually happening. And another thing is that my eyesight, it's not always that great. So I don't know, things come out. Sometimes things are blurry and I just can't see. This is called skilled labor, folks. This is what it looks like. Occasionally you get a hiccup. It's a lot to coordinate. But if you're good with your hands. If you played a lot of Nintendo growing up, you might be well suited for soldering. I don't know about that one. Sometimes you gotta push it, or sometimes when you don't push it hard enough, it doesn't seat right, so... Is this the best way to interface 72-pin connectors to a circuit board? Not really. Is it good enough for now? Yeah. Because ideally the way we would do this is... all right, let's inspect this guy. Let's inspect him. Yeah, let's see. Where are we? I knew a man, Bojangles, and he danced for you. So it looks okay. You know what? We're done. We're done. It's good. It's good. We're done. That's it, guys. We did it. Guys and girls, guys and gals, dudes and dudettes, ladies and gentlemen. Okay. Yeah. All right. Hold on, let me fix my 3D printer. Okay, well, now we got our bypass caps to do. I guess we have to go to the bill of materials here. So, we've got parts for NEStonia from both DigiKey and Mouser Electronics. And the parts that we're working on right now, it's going to be C38 to 63. So I'm just going to look up the part real quick. 0.1 microfarad X7R. It's 50 volts. We can just quickly look at the data sheet. There's not much to say about a ceramic capacitor, but you know, there it is. And yeah. So we'll start C38. All right, so it's a little bypass capacitor for the audio amplifier, the mute input. So we've got our 8 input lines for left and right. Excuse me, folks, I have to tend to my printer. print out these game wheels. It's not that camera. So I'm printing these parts for NEStonia. It's actually the RV10 and RV10 here in the circuit. These guys. And then there's another amplifier here as well. So this is for the input amplifier that uses one of these gain pot wheels. And then there's also the output amplifier, uses the same gain pot wheel. So there's two of them. Just a sec, folks. Yeah, let's check out the stream, see if anything's interesting going on. Apparently not. Apparently not. Apparently YouTube wants to keep me real quiet, apparently. Oh well. I guess that just means I'm gonna have to work harder. Okay, so we got our caps. I'll show you guys this. So we got our caps here. And it's, how many? 26, I think? 26 caps that are 0.1s. We use 0805 for our caps because anything smaller is just, you know, for hand assembling, forget it. It's too small for me. So just gonna bust them out of there. Anyway, put those on the side here. We probably don't need to use a lot of flux, if any, for this project. I mean, for the 0.1s. I'm gonna try these tweezers now. These guys were Avon. They're like $6 or $7. They're not exactly cheap. Alright, C38 is... So the way we're gonna do these caps is we're gonna tin one of the pads on the board. It says nobody is watching our live stream. Oh, I see. It's busted. It's busted. Our live stream is busted. The coolest show on YouTube. 0 viewers. You guys are doing an awesome job there at YouTube. You guys are doing an awesome job. Well, guess what, guys? I got to stream this every day because I've got NEStonia to build. So if you don't want to give me any views, I mean, hey, that's cool. My board's getting built, whether you guys give me subs or not. Just saying, this board's getting built. Looks good to me. It's good to go. She's good to go, folks. Yeah. It's on the bottom side. Guess we'll try and do it that way. All right. So this is for the reset line on the microcontroller. Discharges on power up, and that's pretty much its whole job, is to just reset the micro on power up. I guess we could cruise around the circuit a little bit. Yeah, so there's your micro, the STM32 H562, 250 megahertz. And you got the address registers for the NES data bus for PPU and CPU buses, and we got some registers here for the lights, for the LEDs. And yeah, so that's cool. All right. Switching to our microscope now. We got C38, C39 right there. Pop out another cap here. I just lost that capacitor. I wonder if it fell into the little USB hole. So we lost the capacitor. It'll probably show up later on, though. I guess we'll just have to move on. Showed up at the last minute. Wonder how many gain wheels I'm gonna get out of this. It might be sometimes easier just to use your thumbnail to press down the parts. So it looks good. Okay. Yeah. I guess they think that I'm a lucky guy. But you're not fooling everybody. That might have been too loud. Anyway, it's just rocking out a little bit. Nothing wrong with that. Okay, where are we? I probably am only going to stream for another hour. I mean, there's no point doing more than 3 hours worth at a time. I thought that you were shy. It's the same part. They're all the same. They're all 0.1s. This guy is for, where is that? It's for VBAT. So, if this was so there's no actual battery. So there's a battery inside NEStonia, but not on the micro. Which means that the micro can't really do real time, but anyways, I mean that's just whatever. So where is that thing again? Oh, it's right next to the micro, yeah. The cap is, it's a little twisted. I mean, it's acceptable. But we're trying to do a good job. Maybe we're getting fussy. Well, look at that. We're right at the same as we were before. I guess we're going to have to take it. Missing my wick. Where's my solder deck? It's kind of a little bit extra there. Good enough. It's fine. Yeah. Let's see how long the stream is going for. Now we're at 119, eh? I think after this print, we're probably going to end the stream and just call it the first one. And we'll just pick it up the same way next time. Okay, anyways, moving on. Let's go to... Cool. So where is that again? Oh, okay, I see. Right there. You have to be mindful of these USB pads. This is what happens when there's no thermal relief. It's fine. It's fine. It's fine. It's fine. Yeah, nice. Okay, let's see it now. Yeah. Excuse me, folks. Just have to tend to my printer. Guess we'll peel off another one. I think maybe at at 90 minutes, we may take a break. That'll be about. Yeah, we're gonna take a break. I think we're gonna break for. We're just gonna break for about 5 minutes or so. And we're back. Okay, 42 now. Capacitor 42. And that is right next to the micro. Okay. Trace part. Okay, so this part is for the analog power supply for the micro. So the analog is on a separate supply. And in this case, we run the analog at 2.8 volts. So anyways. So that's that guy there, 42. Sometimes the solder just balls up on the one side and not the other, and it's just, it's frustrating. It's frustrating. Let's pop off another cap here. Come on. Yeah. Can't believe I found that cap that I lost earlier. Well, that's good luck, I suppose. But it's unlikely. It's unlikely you find it. All right. Something weird happened there. There may be a more optimal way to do the parts on this board. We don't actually know what the best routing or part population strategy is currently. We're just doing the point ones because they're critical infrastructure for the power supplies, and so if there is a short, it'd probably be a good idea to figure that out now rather than later on. How's that look? So that was a little messy. Yeah. Yeah, I'm running the whole damn show by myself. All right, let's keep going. Cool. All right. This is just another bypass cap for the micro. It's right there. In an effort to avoid having to deal with too much heat, we'll pick the other side of this pad that's a little bit smaller. Sometimes, like when you're placing parts, and you've got to avoid hitting other parts, and you have to set up awkward situations with your hands and your tools, and it makes it very difficult to do. Some of the parts are a little too close to one another, like these caps. I mean, those are almost too close, but all right. Excessive solder, but acceptable. Well, we're going to need some solder on that C48 anyway, so I suppose. Although we did make a little bit of mess there on C64. We're going to have to clean that up. So, it's fine. We could wick it if we want, but there's no point. There's no parts close enough anyway. Okay. Yeah. Okay. Well, I don't know if we're going to get all the... I don't know if we're going to get all the capacitors tonight, because... I don't know, I mean... This stream could take a long time. Well, anyway, what's next? Right there. Okay. So we got a... It's a double pull, double throw switch. It's an electronic switch. It's MOSFET built, and it's a very small part. It's a ultra thin QFN. That we've so there's a stereo line into the cartridge, and this thing, half of it can select between the microphones and the line in to send it to the cartridge. And then the other half of it arbitrates USB for the cartridge or for the charge chip. But anyways, enough about that. So that guy is just, he just lives over here. Where'd that go? I love it when I can just touch it and make it work. So that was 44. So it looks pretty great. Cool. Yeah. How long are we going now? 149? 2 hours. Let's see if we could, let's see how many more parts we could put on. Because the goal is to work on camera. We're not building NEStonia off camera. Okay. Anyways. .45's on the back. It's for one of the stereo. It's for the right MEMS microphone. There's stereo MEMS microphones. NEStonia has stereo microphones built into it. And the microphones have a shortcut out of NEStonia through the MIDI port. So the MIDI port has 8 pins on it. though you don't necessarily have to get an 8-pin MIDI connector. But if you want to take advantage of some of the extra features that NEStonia has, like the cart line outs, they're direct from the cartridge. There's 3 line outs from the cartridge. Expansion 9, Expansion 6, and Expansion 2. And they all directly go to the extra 3 the unofficial MIDI pins. There's 5 official MIDI pins, and then there's 3 extra that's not used by the MIDI standard. So MIDI cables effectively do not implement these 3 pins for what we've got cart line out on. So there's a little shortcut there. You can get your cart line outs from the unofficial MIDI pins. And then there's a switch on the side of the unit that allows you to switch the microphones onto those pins. If that's useful for anything. So just thought I'd mention that. So it's which one was that again? On the back. We've made a little bit of a mess out of our pad, but unfortunately you guys don't have to see that. $45 is where? Oh, right there. Yeah, you can see right the microphone goes right next to it. The microphone is going to be a challenge because the pads are hidden, and we've got vias on the other side. We've got exposed pads on the other side, so that we can, so that we don't need to use hot air to put that in place or anything. But anyway, that's down the line. Let's see. You see why I use these 0805s, because you can kind of nudge them around with your fingers and stuff, and they're not too small. Not saying it's easy though. I don't know why, but it doesn't look like that pad is wetting. And we're back. So I don't know what's going on with this, but I'm going to put a little flux on that because it's not looking right. And I don't know if it's my eyes or what, but there we go. Oh, but even still, it looks like it's not really wetted well. This is gonna be a little bit of a frustrating one. You know what? We almost lost the capacitor there. All right. It's taking too long already. It's taking too long. This capacitor's taking a beating. It was on the tip of the iron for about 5 good seconds. I mean, you know, the parts are rated for 260 degrees. But you don't want to cook them. So it does look kind of dirty, so we're going to fix it. The plate is grounded, by the way, folks. So just so you know, if you've got some ESD issues, it's so where is that guy? 45. Looks not bad. Looks not bad. Little burn will mark in there, around there. It's no biggie. Let's see what's next. Yeah. Well, we're almost at 10. I think we'll go to 10. Well, we'll see. It's 46 back to the micro. Just another decoupling cap for the micro. So that's it's on the front side. Right there. You can have my credit card, baby, but keep your red hot fingers off of my hot lady. But what can I do when you pretend to be in love with me, baby? It doesn't look like it's seated properly. This is fine. Got a little bit of an issue with that volume button there. Not the volume, the original lights that came with the scope sucked, so I adapted this ring light for it. So that was a little bit of a disaster. It's good. I wonder how we're going to get that crystal on there, because you can see C64 is very close to that thing. So, but that's an interesting challenge for later. It would be especially cruel if we had to remove parts to place new ones because of poor strategy on parts placement. Okay. So all right. That 46. Yeah. Now we're in double digits. All right. Too bad the microphone's in the way of my face, but well, I guess it is what it is for now. Okay, so this one's on the other side of the board for the other microphone. So we already talked about that. All right, 47. I guess we will tack this side. Might be hard to do. Finding a good angle for the board and making sure that I can solder properly is an effort in coordination.
Come on.
All right. Sometimes you might want to use flux, but you know, I'm using it sparingly. So where did it go? I don't know what happened there, but it kind of looked like the cap stuck to the board or something. Oh, come on. How can it stick to that? Are these things magnetic or what? That's good. It's a cold solder joint. It's a cold solder joint. Although it looks like there's some wetting there, but... Okay, we're gonna accept that. All right. Yeah. Another bypass cap for the micro. .48 is right there. It's already got a little bit of solder on the pad for us, so. This isn't going very well. The idea that I could only wick one pad and not the other is the challenge. This is an awkward setup. Can't get it there. C48. It's fine. Yeah. All right. Moving on. $224. Oh. I think it might be about time for another break. I think we'll do one more part, and I think we'll maybe take a break or something. All right. Anyway. I'm losing a little bit of momentum here. All right. So this guy's just for one of the decoupling caps for the LED registers. Nothing too glamorous, and quite honestly, yeah, this might be a case of over-engineering, but the caps are just super cheap. Anyway. 49. Right there. This is a tricky area of the board. Well, let's hold off on C50. That's being premature. Cool. All right. We got another cold solder joint there. Of course, we have to have it right next to the NES 72 pin connector. All right. We should probably clean that up a little bit, because it's like right next to the right next to the chip. Yeah, we can take that. Doing those two chips there, though, that's going to be a hard one, because look how close the pins are to one another. Lots of flux, drag soldering, I guess. Okay. Let's update the tracker. Where was it? Right there. Yeah. I didn't realize I was not on public. I was on... Well, anyways, it doesn't matter. We're back to the show now. We're back to the show. So we're going to find our next part here. C50. It's just right next to it. Guess I'll have to retract that comment about the YouTube management. That's okay. I don't mind. I don't mind saying I'm sorry. Anyways, that was my bad. All right. Well, anyways, so yeah, you can see it's just right next to the other one. So. And since we're having a little bit of problem soldering these guys, I'm going to put a little bit of flux on this. Just for the hell of it. There you go. Not too much. I'm going to peel off another one of these caps. Yeah. Luckily, I was able to change the stream from private to public, but so we gotta add some solder there. So, technique. C49's in the way. We have to turn the board around. Which also means that we've got to wick away that solder. This is one of the more challenging caps that we got to place here. Just because it's awkwardly placed. You always got to keep cutting off the little bits of the solder braid as you use it. We heavily rely on solder braid. So that kind of just worked out. Okay, let's take a closer look. Is it the best? No, but it's acceptable. So that was, how was that go there? 50. Alright. Yeah! Let's see what's going on. Alright. Okay, 51. It's on top. So where does that take us? So it's a bypass cap for the differential driver. It's actually a 1 of 2 decoder, but we just use it as a differential driver for clocking the registers, because the registers are double pumped. So the way it works is when address clock goes high, one of these registers will load with the bus data here, and then when the clock line switches states, then the opposite register loads what's on the data bus. Comes from the microcontroller, and so this whole PB section, the whole B port is completely wired into the bus, and so the control clock and address clock, the data bus, and all of the signals for the NES cartridge, they all come off this B port, which also makes it very convenient when using the general purpose DMA to bus master the NES cartridge connectors. But anyway, that's all I'm going to say about that for now. So that is, it was over here, right? $51. Okay. You know, rather than using a bunch of flux, maybe we can just, you know, give the board a little wipe. That's probably what we should have did in the first place, is just gave the board a good wipe. I mean, I don't know. Well, anyway, we made a mess on it now. Oh my, oh hell yes, honey, put on that party dress. Well, I cleaned the board with alcohol, but we can see that we still need the flux to make this work. You know, back in the old days, like in the 90s, 2000s, seems like there was more flux in the solder wire. But the thing is, though, you know, I mean, with 6337 eutectic solder, like, the whole industry uses lead-free now, so... I mean, leaded solder is mostly for hobbyists. We have a lot of capacitors to do, so we can't be too fussy, you know, like it doesn't look great, but I mean, we'll fix the other side, but you know, I mean, momentum is a thing. Cool. Let's take a closer look at that guy. And it looks fine. Yeah. All right. It's one of the bypass capacitors for the quad 2 input NAND gate there. It's so we have kind of a little bit of a custom USB arbiter circuit here. I'm not going to go into it right now, but the important thing you need to know here is that this is a latch circuit that goes through the power delivery, and essentially, if there's a fault, the latch is switched off. But these power MOSFETs control the power from the V bus into the charge chip. But anyways, I'll shut up about that. So where was that again? Oh, okay. Right there. No thermal relief equals flux needed. All right. Where is it? 91. Flux is a necessary evil when it comes to surface mount. In fact, you can't be successful without flux. I mean, you can try. If you got really good solder wire, maybe. That if you have enough flux in the core of the solder wire, but nowadays it seems like they don't put enough in it. Either that, or they expect you to have complementary flux. So. Anyway. Oh, I forgot to. The part is off center, but it's okay. Where did I nip it? That looks a little ugly, but oh. I'm not quite sure what happened to R25 there. I think we might have took no. I don't know what's going on there, but anyways, the part is good. It's good. Yeah. I'm not so systematic. It's just that I'm an addict for electronics. All right. So, that's just the other one for the HCT 368. I guess I could talk about that a little bit. So the HCT 368s are interesting because they're hex inverters with 3-state outputs, but there's 2 circuits. And so you have 4 inverters that share one common output enable, and then 2 inverters that have another common enable. So this allows you to pick and choose which ones you want to use just as inverters or not, or as 3-state outputs. If we navigate to the NES page, what we see is we do use the 3-state outputs on 2 of the 6 inverters, and you don't see the control here for it, or for this one, that is. These U5E and F, they're hooked up together. Excuse me for a sec, folks. Sorry, folks, I'm a little lost. I just had to do the 3D printer thing, and kind of lost a little track what I was doing here. So, 53, it's on the back, okay. The flux steals a lot of heat from the soldering iron. I mean, that is if you've got thick traces there. Probably check the stream. I'd like to get all these caps placed. We're more than halfway through. There's 26 0.1s. This is all part of the show, folks. It's all part of the show. Making mistakes on live camera. It's all part of the show. It's all part of the really big shoe. Just an old-fashioned love song playing on the radio. It's like a cold solder joint. I didn't get that. I gotta clean that hole. Okay, first things first. This is gonna be hard. We'll have to get back to that one. Well, yeah, there's a little bit of solder in that hole there, but I mean, we're not doing the switches right now. Those are tactile LED switches, by the way. So there's an LED in that, and also a switch, a normally open push button switch. So, take a quick look. We always do a little final inspection here. It's fine. Sounds on the back. Yeah. Yeah. Oops. All right. I'm happy about that. We're getting this done. We're getting this done. This is good. It's going. We're finding this. Where is that? Okay. And on the other side. Ooh, excuse me. All right, another decoupling cap for the micro. So that's going 54. Where is it? Okay, there it is. It's an awkward position. This is going to be a hard one to solder. this is where... So, we have two types of tweezers. We have one type that's straight, and then we have this type, which is rounded, I guess, curved. And so this is one of those situations where we could use this. And maybe it won't be so hard. Which one are we doing? 654. These ones are a little older than the new ones. They tend to slip the parts a little bit. They don't have... See, these Avon ones, they've got textured a textured surface so they can grip the parts, and these ones don't. So all right, let's not get greedy now. There's a rule in electronics manufacturing as far as soldering goes, and the rule is don't touch it more than once. Assuming you do it close enough to where it needs to be in the first place. So that was 54. We gotta touch the other side, and then we're done with that guy. It's kind of ugly. Okay, well, yeah, it looks all right. Yeah. I forgot to do the tracker. Oh, well, that's okay. Okay, anyways, moving on. I can't drive 55. This guy's part of the audio circuitry. Just offers stabilization for the voltage reference there on the op amp. So the non-inverting input has a voltage reference here to 1.4 volts. And so the 0.1 microfarad, it just stabilizes it, filters out the AC, that sort of thing. Keeps it nice and stable. Ideally. Where was that again? Okay. It's down there. Okay. All right. This project has a ridiculous amount of voltage domains. Too many. Probably we could have... Well, it don't matter a whole lot. 'Cause it is what it is. Yeah, I know I'm not doing that right. Sometimes it's difficult to get the part I want to show on microscope and have it in a favorable position, but I've got to pop that part. Where does that go? 55. We're experiencing some difficulties. I think we'll accept that. You ever seen Sammy Hagar do I Can't Drive 55 with Van Halen? Pretty cool. I'm not sure if that's a cold solder joint there. It might be. Dun, 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 dun. Yeah, I know. I don't. I know. I said not to retouch stuff, but it kind of bugs me a little bit. Better. All right. Where is it? There it is. Yeah. I think it's time for another break, folks. Be right back. Back in about 5. All right. We're back. We're back, folks. We're back, ladies and gentlemen. All right, let's see where we're at. Just did 55. It's in the same neighborhood as the last one. It's a decoupling capacitor for the op amp, the 2.8 volt system. You can see the 2.8 volt. That is a minus 2.8 volt regulator there. And so the audio system runs on plus and minus 2.8 volts. So the 2.8 volts, positive 2.8 comes out here, goes into the, it's called a charge pump, and it basically inverts the voltage. It uses the capacitors, I think it runs them at 2 megahertz or something, so this is probably the most efficient part you're going to find in this class. Does 200 milliamps, which is actually just enough for the op amps. I mean, under like extreme loads. So, you know, it wouldn't be realistic, but yeah, it can push 200 milliamps, supposedly. All right, I'm going to shut up about that. We're going to start getting stuff on the board here. It's 56. Where's that? Ah, okay, I see it. In this case, it may not matter which one we tack. So just whatever, I guess. Excuse me, folks. That's cool. You can see the digital readouts on the camera. That's neat. Too bad about the light though, but oh well. All right. What is it? Should probably fix that other pad because I don't know what's going on with that. That looks okay. You can see what happens when you use the solder wick too often. It makes a mess. We'll probably clean that. We'll probably want to clean that. Oh, you know what I think? I think we got a cold solder joint. I can see it. For some reason that took a lot of heat. I don't know why. Yeah, it's fine. Yeah, there it is. 56. Yeah. All right. Okay. Just a point one for the address registers. That's on the bomb side. Anyway, sorry about that. I was just looking at something. Okay, that's better. $57. There it is. Might as well put some flux on it. We're not having a whole lot of luck without it. All right. Think we can accept that? Okay. Boy, if we could cruise through the caps this fast. If we could cruise through the caps all this fast, man. That went well. Yeah. So, is just the other address register? $58. Let's cross the road here. Yeah, we'll do that one. Jeez. I did not mean to use that much flux, folks. Because, maybe I'll just... Still gotta do the micro after this. Anyway, so... Because the thing is, it's so waxy. And, you know, when you get this flux on your hands, you know, you don't want to touch your eyes because it irritates them. So just, like I say, use flux sparingly. But anyways. You cannot see that through. Oh. Got some schmut on it. Did not mean to do that. But cleaned up okay. Somewhere around there. That's 58 there. Yeah. All right. Right. Okay. So it's just another 0.1 microfarad for decoupling the op amps. Anyway, we'll just go. We're just gonna dive into it. RV2 is ugly. That's okay. We'll scrub that later. I mean, we already put flux there, so I mean, do we need more? There's 4 capacitors left. Well, anyways, 4 caps left. We're committed. This is a tight one. This is a tight one. We kind of got lucky there, just thumbing it around. Doesn't look properly wetted. We're live in the bloodstream. All right, what am I doing? We're live. This one. 59. Yeah. That was what, this one? Alright. Okay. I like how this is going. Okay. C60. It's a decoupling capacitor for the opto-isolator, which is... Well, we'll get to that, I guess. So it's for the MIDI in. The MIDI in circuit. And reset and boot 0 are also opto-isolated, and in hindsight, maybe that was a mistake. But anyways, it's enough about that. C60. Doesn't really matter which side we tack, so... Sorry, folks, it's been a long stream. But I used to work in electronics manufacturing 20 years ago. But I didn't get to do cool stuff like this back then. No, I had to build other people's cool stuff instead. Now I get to build my own stuff. Get out of there. I think it did. It's gone. Oh, there it is. Yeah, it's good. All right. Yeah. There it is. All right. All right. C61 is a decoupling capacitor for the analog 8-line multiplexers. And these guys are the ultra thin QFNs. But we'll talk about that another time. Excuse me, folks. I must tend to my printer. I think that 61 is just right there, though. Sorry about that, folks. If anyone's watching. No. Nobody's watching. I guess YouTube's not too generous with the viewers, eh? Shame. All right. '61, '62 are next to one another, so we might as well just do a double whammy. Try and speed this up a little bit. We'll do one cap at a time, though. They're too easy to lose. We are getting a little ahead of ourselves, though. Well, I guess we'll just update the tracker for both parts then. You know, that would be pretty hard to see without the microscope, like the fact that it wasn't wedded to the pad. Yeah, that one's good. Yeah. Well, C62 is just next to it, so... Just for the other T-Mux chip. Got a little circle around that thing. Let's pop them guys off. Looks kind of ugly. I think it's good. It's fine. It's fine. Well, anyways, we got to keep going here. Yeah. Just leaves one cap left. 63. Oh. Yeah, we did 61 and 2 already. Okay. It's on the bottom. We put a 0.1 microfarad close to the MIDI port. Maybe that's over engineering. Why isn't there? It's on the back. Okay, let's see. It's not that close to the MIDI port, is it? I don't know. That's by the R packs, though. That's where it is. Oops. It's not what I wanted to do. Okay, so that's there. Where is it? All 26 caps, baby. We're done. We're done with those caps. And I didn't lose any. Just remember. The placement on that's a little goofy. I'm gonna try and fix it. Better. Now you done buggered it up. You can't do that. Hold on a second. That's okay. Okay. Where the hell is... There it is. Wait until all 163 parts are on. It's going to be impossible to find things. Oh, we lost our camera focus for the printer. So this is acceptable. Yeah. All right, well, let's see where we're at right now. We just did all the caps, and our live stream is, we're at 407, and we did 27 parts. So I think we're done for today, and we'll leave the microcontroller for next time. Four hours for a first live stream. That's good enough. Sorry I didn't enable the live stream until, I don't know. Anyways, we were doing some troubleshooting. And, yeah, nobody tuned in. But we got 27 parts placed. So that's pretty good. Anyway, folks, that's it for today's show. We didn't get to the micro, but we got pretty close. I mean, I guess we could do it, but I mean, it's already been 4 hours. You know. See you next time.